First thing, before I attack this problem, see how it says algebraically? You may totally overlook that, but when it says algebraically, you're not allowed to guess and check. You won't get credit. That's what algebraically is. All right, so if you guess the number 5 and you plug it in and it magically works, you got to show me where that came from. Okay, so everyone good there algebraically? All right, everyone see all different denominators? Let's get them all the same. So let's start with the because hey, this x plus 3's got to stick together. You can't break off the x and the 3 separately. This x plus 3 is staying together. So I'm just going to start with the numbers. 2, 6, 2. What would be the common denominator? 6. Everyone good? Smallest number each goes into 6, 6, 6, 6. But I still have what hanging out to what's left over? That's got to go in there. So my common denominator is 6 times x plus 3. All right. Put your knowledge to the test. What should I multiply this one? What's this first denominator missing that my common one has? 6. So I can do negative 3 times 6. I can do that without showing that. That's negative 18 on top of that one. Ooh, be careful here. What is the 2 missing?
3.
A 3 to get it to make it equal to 6. And the, okay, so I'm going to do 1 times, and I know you can distribute it. You don't need to. I'm just showing every single step individually. X, not 3x, sorry. So 1 times 3 times that x plus 3. Everyone agree? All right, next up, what's that x missing? X plus 3. Everyone's good so far. And same thing, it's going to be the same answer as the 1/2 on the other side, but what's that 2 missing?
3.
So I got to multiply 1 times 3 times x plus 3. Anybody remember from here, once I got all the denominators the same? See you later. Denominators are gone. And I only work with the numerators now. All right, once I get all the denominators the same, and I do whatever I need to multiply with on the top, I get rid of them. So I have negative 18 plus, keep rolling with me, 3x plus 9 equals x squared plus 3x. I'm waiting.
You have to get everything to one side.
No, I don't know. Everything's correct. I'm still waiting on this one. Because what are you distributing? Negative 3, right? So it would be minus 3x, not plus 9, but everyone's seeing where that's coming from because you're distributing a negative 3 here. Nice job, Grace. All right. And then, you know how you started to say it? Combine everything. Yep, combine everything. Clean it up, basically. Clean this sucker up. 3x minus 9. Ooh, look at over here, huh? X squared. That's what I was thinking. Minus 9. All right, what do you want to do now? Can't factor until what, though? You are right. We are going to factor in a second, but not until what? Got to get one side equal to 0. All right, I love it that you said factor in, but not until one side's equal to 0. So let's move all the 3x minus 9 over. You'll get x squared minus 3x. And what happens with the 9s? See ya. All right, what are you going to do with that beast? GCF, take out an x. And we're left with x minus 3. Ready for your 2 answers?
Yeah.
X equals 0 and x equals 3. Okay. I don't know if you're familiar with the whole how the Regents is set up. I'm sure you've taken multiple ones, not only math ones, but other subjects. Do you know how long you have to stay? 2 hours. All right, 2, you have to. If you finish in 20 minutes, you have to stay an hour and 40 after. Why am I saying this? You don't have to do it now because we just don't have the time, but in any time you're solving for x, you never know if you're going to have to reject an answer or not. So what should I be doing with 0 and 3? Checking them. Just store them into your calculator and make sure that left side equals the right side. You have 2 hours there. Instead of just sitting there, gazing around, looking around, thinking about, I think we're in the band room probably if they put us in the same room as last year. All right. We'll be in the band room. All right. So maybe I'll be playing a little drums in the corner. I don't know. We'll see. Everyone good?
I've never been on the I don't know where that is.
Okay.
Isn't it the F wing?
It's in the corner of the school, front corner of the school. That's all I know. All right. Down where the cafeteria entrance, whatever. All right. Everyone good? Because we're all going to get excited for number 30 when we try it. Yeah. Good old graphing. Right up our alley. Yep. You're excited, Jason. Get up. You are. Good. What are you doing on your calculator back there? Wow. But I like that attitude. I like it. All right, now we're getting a little stepping over the line there a little bit. Yep. Just like, I'm checking it. Get off my back. Lay off. All right, I get it, Dom. I get it. We good now? We on good terms here? We're good? All right, good, good. I'll roast you later. Don't worry. I'll get back. All right, so we're going to graph this sine curve. A lot going on. Domain. What's domain? Okay, so I'm not asking you to. I'm telling you this has to be done from 0 to 2 pi. All right, you can't stop halfway. You got to go from 0 to 2 pi. What? How are you going to find what your x values are? What's the process? Come on, it hasn't been that long. What's the process? Got to find key values. How do you find the key value? Find the what divided by 4? Period divided by 4. So let's start there. What's the period of this curve? 2 pi over. What's my b value? 2, yes. So the period is pi. So that means I'm not going to go by pi. I'm going to go key value. I'm going to divide that pi by 4. So we're going to go by start counting by pi over 4. All right, here we go. And by the way, as you can see, I have no idea where these grid lines are, so it's going to be basically a sketch for me. But pi over 4. Next, start counting. 2 pi over 4. If you want to reduce, go ahead. I'm not going to be impressed. Next one. 3 pi over 4. Now I am there. That's pretty impressive. Yep. Pi. 4 pi over 4. But we needed to go to what? I told you in the directions. 2 pi. Keep going. Keep trucking. Keep counting. 5 pi over 4. 6 pi over 4. 7 pi over 4. What's after 7 pi over 4? 8 pi over 4, 2 pi, and that's where we could stop. That's where we could stop. How are you going to find what your y value should go by? Okay. Yep, got to find the max and min of this bad boy. Hey, does this one have a shift? Yeah, it does. Okay, so before I shifted, though, what was my max and my min?
3, -3.
Just like old times. And then you add 2 to it. So what's my new max and min? -1 for my min and 5. So just make sure you go from -1 to 5 on your y-axis, however you want to do it. But that's got to be on there.
Oh, no, my God.
I know many of you, when we did it this unit, you guys like to graph it before you shifted. So you like to graph that one first and then move all your points up too. That's fine. Keep doing that. All right. Just for time's sake, though, guys, today I can't. I'm just going to go right to the graph. What curve are we graphing? Sine. Where does it always start? At 0, but you're not going to graph 0. There's a shift. So all your zeros go up too. So usually, yeah, it's at 0, but I'm going up too. Whew. Do you remember where sine went next? To the max, which is 5 for us. Nice. Just like we never left. 0 went to the max, then went back to 0. In our case, 2. Where to go after that 0? Minimum, -1. Back to 0. And there's one full cycle right there, but we got to go, it looks like one more, right? Looks like we got to go one more. Yeah. Okay, keep grinding. Don't do what the kids did last year and made me go nuts. Just draw a straight line. Because obviously that's the sine curve we talked about for a month. I had multiple people because they tried to use their darn calculators, which we never used in class to do this. And for reasons you don't need to worry about, when you try to graph that, it comes out to be a line. Because they're in the wrong mode. They don't know what window to be in. Darn it, act like you've been there. Any issues? Not bad. That's a nice, I can't believe that was 2 points. It's a lot of work for 2 points. At least 26, right? So we can get right to that 65, at least. All good? Yeah. All right. Had the stuff yesterday. Oh, by the way, probability. I told you we're going to end this unit pretty quickly. Tuesday's the first quiz. Okay, Tuesday, first quiz. Yes. So it'll cover 3 days worth of stuff. How did we go yesterday? We all right? Specifically, population versus sample. Let me just quickly, I don't know how many of you may have tried it or got to it yesterday. There was a question I gave you on the assignment about the orange juice truckload. Real quickly, let's just go over that. What's the population and what's the sample out of that? All right, because this did come fresh off a Regents exam. All right, it was not made up. So what's the population and what's the smaller size, the sample? All right, so population here, if you read through it, what did you guys decide, or you're deciding now as you read through it? What's the population here? Truckload of oranges. Yep, truckload of oranges is your population. And what's the smaller size you took from that truckload? 3 pails of oranges. Yep. The boys are back. There we go. I'll take it. Thanks, bud. Have a good weekend. Thank you. Speaking of problem stats quiz. Yeah, take one on your way out. You'd be surprised some of the stuff I've seen in 16 years. All right. And then number 4, what's a controlled experiment? The biggest part of a controlled experiment, you put them into 2 groups that you select, and then one group gets the treatment, the other group gets some fake stuff, not the treatment, right? And as crazy as you think this is with the toothpaste with ingredient X, it's a Regents question. Okay, where you can be as creative as you want, but again, because it says controlled experiment, make sure somewhere in your creativity you have 2 groups, one getting the treatment, the other does not. Okay, so one gets ingredient X and the other gets Colgate, I don't know, Crest, whatever you want, bubblegum flavored, whatever. Or you can go frozen toothpaste, like it's all around my house, because that's what happens when you have 2 young girls, you get frozen toothpaste, yeah. Not actually frozen in the freezer, like let it go, all right? One job. Jeez. Yeah. Oh, bro. All right. Elsa, Anna. Yeah, I get it now. I get it. Good. Good. All right. Here's the deal today. Still working within your calculator. But here's what I'm going to show you today. How to figure out how spread out some of the numbers are that you are given. All right. So are all the numbers alike each other, or are they all really spread out? All right. So for instance, we take a test in here. All right. I'm going to show you different ways that you could figure out if everyone scored all across the board or they were pretty packed into each other. All right. Alike. One way to do that is take a look at the range, which I think you guys are pretty familiar with. Highest minus lowest for your range. Okay. So that's one way I can see if they're spread out or not. Take the range. So in this case, I got 5 test scores. Range, what's my highest value out of those? 98, and my lowest value, 68. So that tells me there's a gap of what between the highest and the lowest? 30, yes. So the bigger the range, the more spread out they are. I think we can safely say that. The smaller the range, the more packed in they are. If I want to see where basically half the class fit in, I can find what's called the interquartile range. Right? If you guys remember in Algebra 1, you did box and whiskers. You remember finding the quartiles? Okay. The interquartile range is the third quartile minus the first one. So I have a set of numbers here. I need your help breaking them up into 4 equal groups. All right. The first step is, can you guys find the median up there? That's what we did yesterday. They're all in order for you. You're welcome. Can you find the median for me? Find the median. What number's directly in the middle? 86. Yep, there's my median. And sometimes the median, not too often, but it's referred to as quartile 2. Okay. So now how do I get 1 and 3 from there? Quartile 1 is the median of the bottom half. So starting right below 36 here, this set of numbers right here, from 51 to 84, what is the median of the lower half now? That would be referred to as quartile 1. And what's the middle number right now from 51 to 84? 77. So we call that quartile 1. And now guesses on how we're going to find the third quartile. The median of the upper half from 87 to 100. And that would be 92 for quartile 3. So everyone see I've broken it up into 4 groups. 1, 2, 3, 4. And then how do I find the interquartile range? I like to abbreviate that IQR. 92, the upper quartile or the third quartile minus quartile 1, 77. So the interquartile range would be 15. And good news, your calculator does that. I'll show you in a couple minutes. Your calculator will produce that value or help you get that value. Those are all nice and neat, but there's one number that will tell us how spread out the numbers are, and that's called the standard deviation. Okay, standard deviation. You can find it on your, this is just showing you how to find it on your calculator, which we will do together in a second. All right, and I'll go over the 2 different types. What I just need you is a note. This is going to be a number, 25.8. 8.6, 7.2. This is going to be a number, the standard deviation. The lower that number, the lower the standard deviation, this is as much writing as you're going to have to do today, the more consistent the scores. Now, in all seriousness, I'm not trying to make fun of you or be sarcastic. Do you know what I mean by consistent? The more consistent the scores. They're basically alike, okay, versus all the way spread out, okay? And some people, I don't mean spread out like this. Okay. Like it goes from like 20 to 100 on the scores. That's spread out. All right. Just had to cover that. All right. So a quick example. I have set A of these numbers, scores, whatever you think they represent, and I have set B. You guys have no idea how to find the standard deviation, and you're not supposed to yet. But just by looking at these numbers, which one do you predict would have the smaller standard deviation? Which one would you predict had the smaller standard deviation? Why B? They're closer together, aka consistent. All right, then set A is. All right, so B would have the lower one because the scores are closer together. Okay, so do we see the use of this number here? All right, the smaller it is, that tells me, oh, your standard deviation is 1.2. Your scores must be pretty darn close. Versus 25.2, whew, you're all across the board. All right, ready to go to the Millers and the Lopez family. Miller's got 3 kids. Lopez has 4. Can you find the mean for me of both right now? Just find the mean, and I'll show you on your calculator how to do the standard deviation. Just find the mean of each. Hey, what was the symbol we used for mean yesterday? Because I don't want to write out the word mean anymore. X bar, yep. Hopefully you're just using your calculator to calculate it. You don't need a table for this. What's the mean age of the Millers? 12, and the mean age of a Lopez kid? 10. Perfect. That doesn't tell me how spread out they are. Now, we're going to find what's called the standard deviation. All right, so everyone go to your calculator. Remember where I showed you to put the list yesterday. I would like you to teach me, pretend I was not here yesterday. How do I put 10, 12, and 14 into a list? Stat. Edit. Oh, I have numbers in there.
L1.
Highlight the list and clear enter. They're gone. And now you can put the Miller kids in, 10, 12, and 14. You do not need to go to a separate screen for the standard deviation. It is in the same area the mean and median were yesterday. So how do I get there? I wasn't here. Stat. Go over to calc. 1var stats. Now, hey, this is going to be different than yesterday. Do we have a column 2 here with frequency in it? No, so there should be nothing in that column. So you just L1 now, right? Just L1. There's nothing in. I don't have anything in the second column, right? So why am I going to tell the calculator to look there? All right, so it should just be L1, and we're going to calculate. Look at that, huh? X bar 12, just like you guys told me. Now, I just go down for a second. Does everyone see Q1? What's that represent? Quartile 1, median, Q3. So your calculator, you can just do interquartile range by looking there. All right, so go back up to the beginning. Do you see SX equals 2 and this almost OX equals 1.63299? Everyone's have those values. All right, those are 2 standard deviations. Let me go back to my notes. You may have it still. Flip your packet over real quick. Flip your packet back. Leave it right there, sir. Thank you. You too. Behave. There are 2 types of standard deviations. There's population, which is the OX one. That one is population right here. And then there's one called sample, which is the SX, which you guys have equal to 2. Well, which one do I use? If it's not asked for, you always use population, okay? Unless the problem specifically says find the sample, all right? If it says find the sample, then I'm going to use SX. But any other time, I'm going to use population. I call it the ox. Anybody? Never mind. It looks like the word ox. Sorry. All right. Whatever. Sorry. I should just keep teaching math. I know. All right, this just says find the standard deviation. Doesn't tell me which one, so I assume I'm doing the population. All right, which is your OX. Let's go 10th. For you, the 10th. So what are we looking for here? 1.6. And then most of you guys are doing it already. Yep, I got to go back to my list to put in the Lopez kids. Now you guys can clear out list 1. You can go to list 2, but just make sure you tell the calculator where to look. And you can type over these two. I don't know, what was the Lopez kids? 6, 7, 12, 15. And then same thing, ready, stat, calculate, 1var stats, whatever list you put it in, make sure you tell the calculator. Calculate. And now what's my standard deviation? 3.7, yep. I know you could have answered this without finding it, but take a look. Which family had the lower standard deviation? Miller, which means what about their kids' ages? And that's true, right? The Miller kids are closer together in age. Smaller the standard deviation, closer they are. How you guys feeling, all right? What time we at here? 1:51. Any big plans this weekend? Are we good? Moving on. Nice. It's a good event. Nice. Oh, how'd it go? Did you guys have it last night? No.
Tonight's open.
Oh.
I'm not even gonna leave the school. I mean, I have to be here. I would have to be back here at 5 anyway, and the play starts at 7. So I might as well just stay.
There you go. Get a tent going, Gabe, right? All right, let's go. Okay, I don't. All right. Okay, everyone all set? We can talk about our opinions on artificial versus real later. Okay. Later we can talk about it. All right. Determine the 5-number summary for this set of data. All right, determine the 5-number summary. You guys don't remember that probably. You did it in Algebra 1 to create your box and whisker. Minimum, yep, is part of that 5-number summary. Minimum, if I have minimum, I probably have what? Maximum. Quartile 1. Median. And yes, quartile 3. Hey guys, where can I get all these values from? Yep, here we go. Go back to 2 lists now. And I'll give you guys a second to type everything in. Go ahead, type in 2 lists. But now when you calculate, make sure you put L2 in there for your frequency list. And also, as you're typing, because you guys type like you text, and there's no autocorrect on your calculator. I can't tell you how many times people typed in 88 and only one of the 8s got there. That throws off all your values then. All right, so you may just want to take a quick glimpse at the end and say, hey, did I type everything in correctly? Because you'd be shocked how sometimes you may think you touched 87, but it's just 8. All right, here we go. Let's make sure. And guys, tell me if you are not getting these values. because I got to figure out what you're doing in your calculator or what's in your list. All right, so we didn't need a calculator for this, but minimum value, 65. Max value, 100. First time that number's been on some of your papers. Quartile 1. No, nothing on that one. Nothing. Too harsh. Hit too close to home. What? Sorry. Get over it. Quartile 1. 65. Quartile 1. Was it?
Yeah.
Okay, I should have my notes in front of me. But... Okay, hold on. We got to figure. I got to act professional here and actually get my answer key out. $65. If you typed a number in wrong, calm down. Okay. Okay, what are we missing here?
You really? Yeah.
Oh, here's why. You used how many lists?
It's so awkward getting out of the
L1. We put in L1, but you got to also do. Hey, you got to look at L2, and you separate that with a comma. Second, and see how L2 is above that one. L2, and then there we go. Good. All right. We got to update. Do you have a alpha y equals when you do your fraction template? You do?
Oh, his voice.
Okay. All right, because usually something like what comes up on, like you've always had to do L1. Okay. One day soon, see if we can update it so you don't have to do that. All right, median. Here we go. Median. 79, and how about quartile 3? 88. Everyone good with the 5-number summary from your calculator? Okay, interquartile range. That your calculator will not give you. You just got to know the formula though, which is Q3 minus Q1. So for us, it'll be 88 minus 65 or 23. Okay, this is going quick, huh? How about the mean, nearest 10th? 79.5 for X bar. Population standard deviation here to the nearest 10th. You're looking at your ox now. 11.7. All right, here's where I take over now. Any issues now? Because I'm going on to something new, and we got to focus in here this last couple minutes. All right, what's the number of scores that fall within one standard deviation of the mean? All right, what's the mean? 79.5. Within one standard deviation. What was the standard deviation? 11.7. So here's what I'm going to do here. I'm going to take the mean, and I'm going to add a standard deviation, 11.7. And I'm also going to subtract a standard deviation to see if it's within 1. All right? Within 1. So between what scores? And how do I find those scores? I add the standard deviation, and I subtract it from the mean. So 79.5 plus 11.7. 91.2. And at the other end, 67.8. How many scores within? Now, within means what? In between or on the outside? In between. So how many scores are in between here? 67.8 and 91.2. That's what I'm asking you for. Go back to the frequency table. Here's what a lot of rookies will do. Does 100 count? No, that's outside. I need inside, within. 95 count. Okay, 94. Woo! 88. 85. 79. 74. 65. I heard some yeses and nos on that one. It's on the outside, right? Here's what rookies will do. 1, 2, 3, there's 4 scores. No, this is a frequency table. How many times did 88 occur? Yeah, not once, 3 times. So I need to count all those frequencies up. So I got 3 times, 4, 5, and another 3. How many total scores? 15 scores fall within 1 standard deviation. Within 1. Cut it there. Within 1. Between. Everyone good? All right. Oh, some of you guys are going to start getting the shakes now in this next one. Probability. What's the probability that I pick a score that falls within 1? Just stop. It's fine. You did the hard work already. How many scores fall within 1? You guys did the hard work already. How many scores are within 1? 15, but it's asking probability, so I need out of. No, don't tell me the number. What are you going to put on the bottom? Don't tell me the number. Total. There you go, the total. So 15 out of how many scores total? Add that. You can either add up the frequency or just, hey, look at the beginning of the problem. It told you. Right, Ian? You like that? Yep, you and your fresh cut. 15 out of 30. Don't be ashamed. I like it. I think everyone else is in the same boat. Looks good. I like it. You got the wave going there today, too. That's nice. Did you add that in today or a little gel? Nothing wrong with gel. I throw a little in on the top there. Excuse me. I got a little out here to style. All right, got a little style. No? Or are you saying I'm balding? I think that's where you're going towards, right? It's okay. Hey, I'm not ashamed. Wear it proud. All right, final one. What percent of scores? Okay, now I'm not asking within, so I need you to think about where I should go here. Fall more than 1 above the mean. More than 1 above the mean. So if I go back to that range I had, what am I looking for? Scores that are above 1, more than 1 above. Scores that are greater than? Scores that are greater than? 91.2. What if I ask 1 below the mean? 67.8. All right. Within is between. More than 1 above is out here. More than 1 below out here. All right. So go ahead. How many of the scores are 91.2 or above? 6. Right? Okay, but it's asking me for percent. So how are you guys going to do this? I know there's 6 scores. What do you want me to do? 6 out of 30 would be what percentage? 20%. Okay? Don't pack up. Go turn it. Let's go turn it. I want to get a little practice in if you're not going to do any of this weekend. Here you go. You got a new table to fill in into your calculator. Get rocking and rolling. I'll walk around if you need any help with the calc.